my task was to expand a little bit on the stationarity is dead paper published in Science as a policy forum piece in February of 2008. And I think I want to accentuate what other people have said, and that is that Chris is in fact a master of the English language. When Chris suggested the title, I was kind of flabbergasted. When you look it up in for example, the Gramophobia blog, it says today wither has a flavor of antiquity and is rarely used except by those who like its quaintness. And so that was Chris, I guess. I mean, I hadn't heard wither since my senior year in high school, when Monty Python's Flying Circus had an episode called Wither Canada. So maybe that's where Chris actually got it. The authors are there on the screen, and this is a question for Chris later, and that is, how the heck did he pick the authors of this wonderful paper? I'm at a loss why you picked me to be on this paper, but I sure am glad it's my most cited paper. So I think we've already been having a discussion about the stationarity is dead paper, the idea that natural systems fluctuate within an unchanging envelope of variability, which is a foundational concept. We use these probability density functions for either stream flow or annual flows that has a time invariant PDF, and its properties can be estimated from the instrumental record, but we have to assume that the mean and moments of the distribution are random through time, which is a lot, but we can use the PDFs to assess and manage risk to water supplies, waterworks, and floodplains. And we've already talked about why it's dead, and that anthropogenic climate change is altering the means and extremes of precip, ET, and the rates of discharge in rivers. The second part of the paper dealt with stuff that I was really fascinated by, and that is, the observation that now, the projected changes in runoff during the lifetime of major infrastructure projects were large enough to push hydroclimate beyond the range of historical behavior. And now we face these dual challenges of renewing or decaying water infrastructure and then building new infrastructure, not just in the US, but globally, in places that didn't have very much infrastructure to begin with. So there was a sentence in there that, in rereading the paper, reminded me of how much time has gone by since that paper. Now, meaning 15 years ago, is an opportune moment to update the analytical strategies used for water planning under an uncertain and changing climate. And when the paper, when we turn to possible solutions, it reminded me very much of something that's going on, right now, which is, this exciting but uncertain field of exascale models. Destination Earth, Destiny as it's called, these digital twins that are able to let us examine, things like the construction of dams, irrigation of crops, harvesting of forest, land use changes within the framework of climate model, in collaboration with climate scientists and resource scientists and managers. And it's very reminiscent of the Harvard water program, which was actually the brainchild behind stationarity in the 1950s. And I think Chris and also Dennis Lettenmeyer and others have been pushing all along since we published this paper for sort of a reinvigoration of the Harvard water program to do exactly that. So everybody's a critic, as well they should be. So there were a bunch of papers that were published after the stationary is dead paper that were critical, mostly because they argued that there were a lot of things, including long-term persistence, long memory processes, and conditioning, could introduce sampling errors that could contribute to them being mistaken as non-stationarity. And these papers were, the first one was by Harry Lentz and Tim Cohn, two USGS employees, hydrologists. In 2011, there was another one by Nick Metalis, who was very opinionated, but oftentimes right. Montanari and Quotso-Yanis in Water Resources Research, another one by Serenaldi and Kilsby in 2015, and then a very elegant response by Chris and others to those critiques. And again, when you read Chris's stuff, what always catches your eye, as Zuki mentioned, was just the elegance of his writing. So in some places, stationary was considered long dead before global and regional climate exited the envelope of natural variability. And I don't know, maybe one of the reasons why Chris engaged me in this paper is that I was a place-based scientist that spent quite a bit of time, over 30 years in Tucson and working in the Western United States. And I also worked a lot with colleagues like Bob Webb on the environmental history and the dynamics of the Santa Cruz River, which runs from right to left there past Tucson. And I was actually around in the late 70s and of course in the 80s. And I kind of saw this, people really struggling with how to manage the Santa Cruz River floodplain and other floodplains in the southwestern U.S. and dry alluvial valleys where there's, they're dominated by major floodplain changes, not just in terms of urbanization, but cut and fill cycles. And, you have very unstationary channels that are, make it really difficult to assess flood stages. And in the 60s and in the 70s, of course, you had the National Flood Insurance Act of 1968, and then followed by the Flood Disaster Reduction Act that kind of mandated that people estimate, in particular, 100-year floods and in the inundation that would result from them. And Tucson was no exception. So one of the things that makes it really difficult is that these dry alluvial valleys are stratigraphically complex. On the left is in that reach of the Santa Cruz River that's right across from Tucson. You can see this complexity of cut and fill cycles along the Santa Cruz, but they kind of kept going throughout the last century or so. The picture on the right is a head cut that developed in an unincised floodplain right across from Tucson in October 1889. And just a few months later, this is what that exact picture looked like, with the head cut migrating about 3 kilometers upstream in a matter of weeks. Here's another picture in February of 1915, where a huge flood in the winter of 1915, basically, cut a big meander bank and left the Congress Street Bridge sort of high and dry. And then again, there was a big flood in October of 1983 where the issue was not inundation at all. It was actually channel changes that were caused by a huge event of 50,000 cubic feet per second. So along the Santa Cruz River in Tucson, there's been a huge number of estimates of the 100-year flood. You know, the first one was in 1937 with an estimate of about 12,500, but then estimates have fluctuated quite a bit, particularly after the event in October of 1983 that was caused by a dissipating tropical cyclone with the moisture pulled in for about 7 days straight through a cutoff low. And at that point, after the 1983 flood, Tucson, the city of Tucson and Pima County kind of gave up, and they ended up using rainfall runoff modeling to pick a regulatory flood of 60,000 cubic feet per second, a design flood of 70,000, which were alternate methods recommended in Bulletin 17B at the time. But, you know, they did that in defense because they didn't want to see happen again what happened during the 1983 flood. So basically, the 100-year flood, estimates of the 100-year flood were kind of thrown out the window. It wasn't just channel changes that were responsible. It was also the fact that decadal to multi-decadal variability in the size and seasonality of peak flows complicated matters quite a bit. The annual flood series in the middle panel is at the bottom. And before 1930 and after 1960, half of the annual flood peaks occurred either in the fall or in winter, whereas between 1930 and 1960, they all happened in summer and there were relatively low flows. So you can really track how climate variability and the changes in size and seasonality of peak flow affected the non-stationarity along the Santa Cruz River. So I want to turn to some early signs that I saw that stationary is dead would have very, very broad appeal. The first one happened very quickly in 2009. I got a call from from an environmental economist that was working with another one, Robert Repetto, who used to be at Yale but is now, I think, a fellow at the Pew Center, but also at the World Resources Institute, and Bob Easton, who was at the University of Colorado. And we had kind of a long conversation about the stationarity is dead paper, and they said something that got my attention right away. And they said, Julio, they called from Boulder. They were actually doing some back of the envelope calculations at a restaurant when they called. And they said, you know, the estimates of how much the renewal and building of new infrastructure was going to cost, you know, over the next years to decades, because of the uncertainty in the stationary assumption. Basically, they were going to cost probably twice as much as people were estimating. In 2009, the American Association of Civil Engineers was estimating that about $2.2 trillion would need to be invested. They do these report cards every 4 years, and I think the last one in 2021, the estimate was $6 trillion, and they haven't taken into account non-stationarity yet. And so it could be that the cost is actually more than $10 trillion over the next few years. The other person that I had conversations with was an environmental lawyer named Robin Craig, who then was at Florida State University. She's moved around a bit. She's now at the USC Gould School of Law, where she has an endowed chair. And in 2010, she wrote a paper in the Harvard Environmental Law Review that really caught everybody's eye. It was some of the stuff that she was saying. I don't think I'd thought through myself. There's a quote from the abstract that I'll read to you real quick. Environmental and natural resources law are currently based on assumptions of ecological stationarity and pursue goals of preservation and restoration. So what that means is that the law says you have to preserve the environment, and if you screw it up, you have to restore it to what it was. Both of those are stationary assumptions, and they don't fit goals. They don't fit a world of these assumptions, nor those goals fit a world of continual, unpredictable, and nonlinear transformation of complex ecosystems. And Robin and a few of her colleagues have written several brilliant papers about this. So this paper has had a lot of broad appeal. It's been cited many times. Web of Science 2600, almost 2700, Scopus 2947, Lens 3376, Google Scholar 4674. And one of the things that's really impressive is that the paper continues to be cited at a fairly high rate, averaging about 250 citations a year. It's pretty remarkable for a very simple but extremely well-written two-page paper. It's also been cited across lots of different disciplines, which is pretty impressive. Even in economics, it's been cited quite a bit. So I actually started reading Twitter feeds about the Stationary is Dead paper, and my favorite was that if I were in a band, it would be called Stationarity is Dead. And I want to end by saying that I'm really fortunate to have been on this paper with Chris, but also super fortunate in 2009 to have celebrated together with Chris our election as AGU fellows. And Chris, I have been such a great admirer of your work over the years, and I've really appreciated your friendship. So happy retirement. Thank you.
I love that picture. Julio, it's great to see you in the picture there, but also in live in the flesh. You're looking good. Thanks so much. Yeah, you were selected. I mean, I wanted you on that paper because of that experience with the sort of really the low frequency climate variability and how that sort of confounds our efforts to distinguish climate change from the stationary world. So yeah, I mean, I was going to kid you and say you guys were the only ones that would agree to be on the paper, but that's never not the case. No, you were the best I could think of. And I was so glad with, the contributions that everyone made, including you. And it was nice that you reminded me of those contrary papers that came out before our response to them. There was some really, there was some language in those papers that I was tempted for us to put into our commentary on them, but they were a little harsh, and I thought, no, we'll leave them be. I don't know if you remember, but
yeah, I do remember. Yeah.
Anyway, thanks so much. It's really good to see you.
Thank you, Chris. Great to see you as well.